Okay, good morning, everyone. Let me recap what we did, and we are coming to a very interesting topic today. One of my favorites because moderator was something I was very scared of 3 years ago, and moderation, mediation, regression, lines. I'm a person who's very scared of maths, but I've just simplified it a little. We will be doing it today. Let me just line up what we have done. We started with a selection of a study from Google Scholar. We saw that there should be no published study. Okay, we chose a topic. We did a PICO, okay, population intervention, etc. Then we made a Prisma, a protocol where we said what we should include, what we should not include. Finally, we came to some it's an example. 112 papers if we have to do an SLR, and some 31 to 41 papers if we have to do a meta-analysis. We took those papers and made Excel sheets. I showed you the Excel sheets yesterday for each bivariate relationship. After making Excel sheets, I picked up one bivariate relationship, attitude and intention. I put all the 10 to 20 studies which I found where I had the correlation value of attitude and intention into the software. The software gave me an effect size. The software gave me two effect sizes, one fixed, one random. I had to choose between them, and I explained to you the concept of how to choose, the logic behind fixed and random. Suppose we chose the random. We reported the random for attitude intention for say 19 papers, total sample 6,000 something, which I showed you in the paper. Finally, we went to heterogeneity values. Just reporting the effect size wasn't enough. I have to show the pattern of my study. I calculated heterogeneity. Heterogeneity was calculated from an eyeball test, seen from an eyeball test of the forest plot, Q value, I square value, tau square value. Okay, in between there were terms like, which are going to come today also, within study error and between study, within study variance and between study variance, within study with fixed model, within and between in the random model. These terms are going to come today also. Finally, we get our heterogeneity figures and we decide whether we want to take up a random or fixed. And I told you all this justification in a research paper. So parallelly, I'm taking you to a research paper and how to report it. Now, let me go to today's topic. Give me a minute. I'm just sharing the PPT. So, okay, now, again, if any of you thought that we can just report the effect size and work was over, or we can just report the values of heterogeneity and work is over, again, you're mistaken. We have to go further. There is more to meta-analysis, and this is all only stage one. Stage two, of course, Kaushik sir will come to on 26th. So once we have calculated heterogeneity, I showed you a paper yesterday where he said 90%, 92%, 85% heterogeneity. Having heterogeneity is not wrong, but you have to give me a reason of heterogeneity. And the reason of variance or heterogeneity is something that we have to now explain in our study. So what are we doing? Starting from heterogeneity values to what we are going to do today, which is subgroup analysis and meta-regression, we are just explaining the pattern of our secondary data of 31 studies to the editor. That's all we are doing, okay, or to the person who's reading our study. Okay, so there is something called a subgroup analysis. Okay, there's something called a subgroup analysis. And what is a subgroup analysis? It's very simple. I divide my data into two groups. Now, why am I doing it? Try and understand. I'm trying to justify the heterogeneity. So why am I trying to do this? I'll give you a very simple example. There was a research done by, and all this comes from the medical field. So I am giving you medical examples also, and I'll give you social science examples also. So it so happened that there was a research done on effect of a particular iron tablet on hemoglobin of a person. So this research was done, and it was done on some, say, for quite a few samples, and a person said, okay, let me do a meta-analysis of it. So he listed all the 200 papers where people had studied the impact of that iron tablet on hemoglobin of a person. Now, after he did the study and he came to the heterogeneity value, he found that after meta-analysis, the heterogeneity value was some 92%. And I have told you, heterogeneity is not that big a problem in social sciences, but in medical line, it's a very, very big problem because humans are involved and life is involved. So he went back and he studied that what is the reason of this heterogeneity, why there are so varied results, that 92% heterogeneity, and it's a medicine you're going to give to a human being. Why is there a variation in the data? And he found out that he had taken a mix of male and female samples. So he had taken studies which were only done on females, and he had also taken studies which were only done on males. And of course, the male female hemoglobin is different. Thus, there was a variation. Now, all this that I've explained you in very, very simple terms of finding out the need of that reason of that variation, the same thing we are going to do through statistical methods. So, what is a subgroup analysis? What is a subgroup analysis? Subgroup analysis includes splitting the participant data. What is my participant data? 31 studies. The ones that I shortlisted for my meta-analysis, that is my participant data. So the subgroup analysis involves splitting the participant data into subgroups. You could ask me a question, how would we know the subgroups? You would know the subgroups only when you go back to your 31 papers, study them one by one, and judge yourself what is different in these papers which could have led to heterogeneity. I repeat, how do you come to know that one variable on which we should be splitting the data? You have to go back to 31 papers. You have to analyze, read them and analyze them and see what is different. Let me give you an example. I was doing this paper that I showed you, Urge to Buy. Okay, and I wanted to divide them into subgroups. Now, I mean, of course, I have seen some A-grade papers which I study so that I can do this. So most of the common, division subgroups that I had got was location of the study. Okay, so people used to divide these 31 papers on the basis of location. Some used to make two categories, Asia and non-Asia. Some made some continents. Some made categories of Eastern countries and Western countries. Okay, so 31 data was divided on the basis of location into subgroups. Now, what I did is, and it's a part of my learning I'm sharing because this is not written in books. So there is some dispute. So there was I was a little fascinated with the SEM and PLS-SEM because it's a new technique. So what I did is I divided my 31 papers on the basis of papers which had SEM, worked on SEM, papers which worked on PLS-SEM and other techniques. So if I have a paper on correlation or I have a paper on t-test or whatever, I put them into one category. SEM papers I put into one category. Yesterday somebody had asked also that can we take SEM papers? Yes, most of the papers that land up over here are SEM papers because they are the ones who have correlation tables, unfortunately. So I segregated SEM papers, then I segregated PLS-SEM papers, and then I segregated others. So I made 3 subgroups. SEM, PLSM, others. With all due regards, although Neeraj sir has told me not to talk about rejections, but they are my experiences. So what happened is I didn't get a rejection, but there was a major revision which came from the reviewer. He said, and we have to listen to the reviewer. He's a much experienced person than us. And we are in, I feel I'm still in a learning process. So he writes back and says, PLSM and SEM are primarily the same techniques. Why have you made a subgroup of these two? There was no need. So I made this subgroup because I thought it's not there in any paper. I will have a niche. I will have a niche variable. But the reviewer said that SEM and PLSM are primarily the same techniques. You can't divide them into subgroups. Now, if you ask me the question how to divide into subgroup, of course, you go by your knowledge. And my suggestion to you, if you're starting papers, meta-analysis paper, please take the very common subgroups. Males, females, location of the study, Asia, non-Asia. Let me go further. Sample size, below 500, above 500. Also, you could go for product category. Okay, I'll give you an example of how I made a subgroup on the basis of product category. So there was a paper I was doing on religiosity and the impact of religion on attitude and purchase intention. I've been speaking about it. So I had to divide the category. So most of the papers, see, you have to go back to papers. I went to 31 papers and saw the category on which this study has been done. Religion has been seen as a moderator. So I found out that out of 31 studies, some 20 studies were only on halal products. Now, this is not coincidence. Nobody can tell you, it is not written in books. You'll have to do it yourself. There are no shortcuts to research. So you'll have to, I went back, I studied, and I wanted to take the product as a subgroup. I wanted to divide those 31 studies on the basis of product. I went back and found some 20 studies. 20 studies were on halal products, and the rest which were left were on normal products, say other products which were non-halal. So I made two subgroups: halal products, not halal, non-halal products. Okay, so this product became my subgroup. So how do you decide on a subgroup? You go back, you study, you make subsets. I also take help. I also take help from the previous papers in my domain. Okay, so if there is a previous paper, although it might not be on religiosity, on some other things related to religiosity, say ethical concern, etc., I take cues from there also. I go and study their moderators, their subgroup analysis, and take cues from there. Okay, so that is how you. So if you're asking me how to divide a subgroup, it is going to be done by you by studying the papers and some references from A grade journals. Okay, so what are we going to do after? First thing is we are going to divide it into subgroup. Now what are we going to do? Let me tell you what we are going to do. Okay, this example I've already given you. Now, just suppose that we have a set of 31 studies on education, and we go back and we divide them into subgroups, and we see, we don't divide that. It's not a pre-planned strategy. I'll have to go and study the papers and see. So I go back to my papers and I see that, okay, these papers are being divided into, say out of 31, 20 studies have been done on online tutor, and somewhere around 11 studies have been done on the offline tutors, the real tutor, one-to-one, face-to-face. Okay, so I make two subgroups. I divide 20 papers, online tutors separately. I put those 10 to 11 papers of real tutors separately, and I calculate an effect size of each of the subgroups separately. This is what I'm going to do. And how does it look like? It looks something like this after analysis. So this is a study where there were a set of papers. Okay, there were a set of total papers, say 40 papers. Okay, so let me get rid of this. Yeah, so there was some total, you can see there were some total set of papers, say 50 or 60. uh, we tell the software that, listen, we want to divide these papers on the basis of males and females. We tell the software out of 31 which is male and which is female. You have to tell the software, it's not going to do it automatically. And we are going to do that in the software also. So we tell the software this is male, this is female. And then after just clicking analysis and telling it to do a subgroup analysis or telling it to do a meta regression, the papers will be divided into two categories automatically. Now, what is happening over here, let me explain to you. So this is supposed to be the consolidated effect size of all the papers which had male respondents. This is supposed to be the consolidated effect size of all the respondents who had female participants. After dividing into subgroups, what should I be seeing? I should be seeing my I square. Look at the I square. Okay, heterogeneity. Once the papers have been divided, the heterogeneity has come to 0. What do you conclude? How do you interpret this? How do you interpret this? You interpret this in a way saying that all the heterogeneity in those 31 papers was attributed to this one factor or one moderator, which was male and female or gender. But in every FTP, in every workshop, whenever someone brings data, he or she brings perfect data. So I have always seen in a SEM SEM workshop or in a workshop on AMOS, the model always works. The data is such that the model always works, and there's always that red light which goes on, which means the model has worked. In real life, it's not so. So similarly, over here, I'm showing you a perfect data. A data where a subgroup analysis has been done on the basis of male and female, and heterogeneity has come down to 0. This might not be the ideal case in your data, but even if the heterogeneity is coming down to some extent, I'm not saying 0, it's coming down to some extent, you can say that the reason for this heterogeneity is this one factor, gender. Okay, so this is one method. This is just one method of explaining heterogeneity in data. Now you might ask me that this has just been done on one variable. There might be 10 such variables. So please go ahead and do a subgroup analysis on 10 such variables. If you feel there are 10 moderators, there are 10 factors in your research which are bringing in a variation, okay, you have to go ahead and actually do it. So let me show you here. I'm going back to my just a second. All drawings, come to normal mode. Yes. So I'm just showing you yeah, so this is a file I've made. Yeah, so if you see, yesterday I told you to just make a bivariate relationship, correlation and sample size. So here you can very well see in my file, these are my so-called moderators, or these will become my subgroups. Okay, so what I do is, when I make an Excel sheet of the bivariate relationship, correlation and sample, when I do this along with it, because you are anyways reading a paper, okay, so if I've taken this value of 0.3, I must have taken it from my first paper of raw. Okay, so while I'm studying raw and taking his correlation matrix and taking his sample size, then and there I have a set of planned moderators or planned subgroup variables, and I start picking up and listing the data of that. So this is planned. Year of publication was planned. I mean, before you collect data, you have to do a planning. And it's not only that you just take from an A grade paper, okay, year of publication was one subgroup or year of publication was one moderator. It's not that way. You have to defend these moderators with literature. Okay, so coming back to the paper again, which came up with major modifications, one of the comment of the reviewer was that it seems that you just did an analysis of the moderator. You're supposed to be justifying it in review of literature. You have to prove it first through theory that year of publication could have an impact on meta-analysis of these studies. So the first thing is, when you select a moderator or when you select a subgroup analysis variable, you have to first prove it through literature that this can make an impact. It is then that you take it and test it in meta-analysis. Okay, so it's not that initially you don't plan, then you find out effect size, then you go back to those 31 papers, then you feel, okay, I think this is the difference. No, we don't think and feel in research, we prove it through sources. So you have to first study what could the moderators be. You have to see if that moderation has shown any impact in literature to your study, to attitude intention. To your study means I'm still on that one bivariate. Attitude intention. Okay, you have to see if location. So if you are taking location as a moderator or a subgroup analysis variable, you have to see if location has ever made an impact in the relationship of attitude and intention. And if you get a reference, only then can you pick this up as a subgroup variable or a moderator variable. Okay, so that's about subgroup analysis and how you do it. So this is the table, this is the output you will get, whether you do it for male or female, whether you do it for location. So if you are, depends on how many categories you are dividing it into. Okay, so if you are dividing location, generally in my research papers, I divide location into Western countries and Eastern countries. Okay, I have supportive data, I have supported review for that consumers behave differently in Western countries, consumers behave differently in Eastern countries. I have data for that. I have data that the attitude intention relationship is different in Western countries, different in Eastern countries. I have data for that. Only then have I taken it up as a subgroup analysis. So generally when I do this analysis, I take up two categories, Western, Eastern. You could take up in location some 7 categories based on continents. There are times when we take up, like I told you, religiosity, when I found out that there were more papers on halal. Okay, and I found that all the research, 31, was so biased towards Muslims and how they feel about buying products. So in my location, I made a category called Arab and non-Arab countries. So it depends on your research. There is no hard and fast rule that this is the category. You'll have to go back to your research and see. Okay, but the moment you say, okay, I'm going to take 2 subgroups, Arab and non-Arab countries, you will have to go and support it first with literature. So I have supported this with literature and shown in my paper that the consumer behavior of Arab country consumers is different from non-Arab country. I have also proven that the attitude intention relationship is different in Arab countries vis-a-vis non-Arab. So I have done that. I have supported it with literature, then taken it as a subgroup, then gone to the software and done this analysis and shown to them. Okay, I hope subgroup is clear. Okay, now let us go to the sir, there's a disturbance, a continuous disturbance, sir. Somebody is not on mute. Yeah, somebody is not on mute. Can everybody please mute yourself? Okay. Yeah. Now the flaws in subgroup analysis. See why we went to meta regression. After this, I'm going to come to meta regression, but you have to understand why we came to meta regression. Subgroup analysis was more than enough. Male, female, Arab, non-Arab, it was more than enough. There was no need of moderation. But a subgroup analysis is just dividing the data into two groups. Okay, meta regression is into regression and moderation impacts. Okay, and it is a little different conceptually. Also, it's a little different. When I come to that, I'll let you know. But one of the flaws of subgroup, which is not there in regression, is that in subgroup, authors say, the academicians say, you break the data. You break the data into male and female. You separate the data, and the number of studies become lesser. Okay, in meta regression, that does not happen. Further, when Kaushik sir takes you to meta sem, even when he takes to meta sem, he'll take with all 31 studies. He'll not break it up. In subgroup, you break it up. Okay, but if you want all 31 studies to go, and then you put a moderator and all 31 studies be studied together, then you have to go for meta regression. So the only flaw in subgroup is that the data gets broken. The data gets broken, and that is what academicians say. Some say, I'm not saying everybody says, but I have read it in literature, that this broken population, or the broken studies, 31 studies divided into 21 and 10. Okay, so that is the major problem of subgroup analysis. So now let us go to the next technique of the day. Yeah, I'm on time. Yeah, meta regression. Okay, I generally I have a mixed audience, so I do explain a little, because this is where confusion starts. Okay, so this is meta regression, and this is being done on secondary data. Most of the times participants have heard about regression, and they have done it on primary data, so they confuse between meta regression and regression. So I am very simply explaining the difference of regression and meta regression first, because when I go to the software is going to take 2 minutes. If the concepts are clear, all I have to go to the software and just click a few buttons and you'll see those pictures. So please understand the concept, because if you don't understand the concept, you'll not be able to write it in a paper and defend it to the reviewer. Okay, meta regression. So before I come to meta regression, there is this one name which I was very scared of when I started learning statistics. A moderator is a third variable which affects the strength of correlation among two variables, one dependent and independent. Here in my case, the dependent and independent are attitude and intention. And the third variable which I'm seeing should affect the relationship is religion. I repeat, in the study that I've been doing right since yesterday, my dependent and independent variables was purchase intention and attitude. And the third variable which I'm seeing might affect this relationship is the religion. Okay, so I'm very clear about my moderator. But for those of you who are new to moderation, I do generally have a few PhD scholars who are new to moderation. I'll just take 1 minute, and the ones who know it, please bear with me. Just 1 minute to explain what's a moderator. So it's very simple. So if a father yells on a child and he cries, this is a direct relationship. Okay, but even in the family, there is one person who can affect the strength of this relationship. Okay, so this I came to know from a few students that I have, young students, graduate students. I asked them that when in our times, when our fathers used to scold us, we used to cry. Do you cry? They say we cry if the mother is not there. If the mother is there, we don't cry. Okay, so here the father is yelling on the child. This is a direct relationship. The father here is the attitude. The child here is the intention. And from all the 31 papers, what have I collected? I have collected this direct relationship of the father and the son, attitude and intention. But what am I seeing now? This one lady that you see, which is the mother, is a very effective moderator. If she comes in between, she can impact the strength of this relationship. She can dilute the strength of the anger of the father. She can dilute the strength of the reaction of the child. So she is the moderator. in my study, this is a very normal everyday life example. In my study, the father is attitude independent variable. The child is intention, purchase intention dependent variable. And the mother's role is being played by a third variable, which I feel. I don't feel, I have review of literature to prove it. I don't feel in research. I have review of literature to prove it. I feel religion could be one such. Religion could be one such moderator which could affect the strength of the two variables, attitude and purchase intention. So I hope for those of you who are new to moderation, this concept is clear. And this is exactly what we are going to do. Now I hope you'll understand the difference between subgroup and moderation, meta-regression. I hope now what we did in the subgroup and what we are doing in meta-regression, I hope now it is clear to you what we are doing. So this is what a normal regression line looks like. I'm assuming you're clear with the concepts of regression. The most important two values that come out in regression and so also in meta-regression are going to be the beta coefficient, which should not be 0, okay, and of course the p-value, which should be significant. I have already explained yesterday also many a times, less than 0.05 means significant, means the moderator is making an impact. Something, please understand this like that. So there's going to be a beta coefficient which should not be 0. You'll see it in in the software also. There will be a significant value which you have to check, and that is when we come out with whether this factor is impacting the other or not. Now, this is, those of you who know regression, you must have seen this graph. Okay, so the blue line is the best fit line. Okay, and all these red colors, dots that you see, they are probably your values. Okay, and generally when we do a regression and make this graph, we are doing it on primary data. Okay, we are generally doing it on primary data. For example, we are calculating the impact of traffic on pollution. Okay, so we have two variables. We do a regression analysis. We plot them on X and Y axis. Here the two variables are height and weight. You can see in the graph. We plot those two. Okay, a linear relationship, a perfectly linear relationship, the best fit as it is called. The blue line is called the best fit. But the data always is scattered. The data should be scattered just nearby the blue line. It shouldn't go out too much. As we say layman language, it shouldn't go out too much. If it goes out, it becomes outliers. Okay, so these are the very basic concepts of regression. This I'm just taking 1 minute so that if somebody does not know, because then you'll not understand a meta regression. The other concepts, you know, they were very, very new. So you didn't have to have a basis of any statistical knowledge, but this you have to have a basis for me to take you forward to meta regression. Okay, so you've understood regression. Now, what is the meta regression? In meta regression, what we do is we want to see if the effect size. See, we've already calculated an effect size. What effect size did we calculate? We took 31 studies, put the values of attitude and intention for all those 31 studies, and we calculated an effect size. The effect size came to 0.79. Now, I want to fit in a moderator. I want to bring in the mother. We have calculated the father and son's relationship from 31 studies. Now I want to twist it a little. I want to fiddle with data. I want to change the data a little and see if it changes or not. So I want to introduce a mother. Okay, maybe to some extent a grandfather. Maybe to some extent the friend of the child. I want to bring in 2-3 moderators and see if this direct relationship is changing or not changing. Okay, and these variables are called explanatory variables also. So one very simple example of what we are trying to do, and we are trying to do it not with one moderator, we will be trying to do it with 2 to 3 moderators all together in this direct relationship. So one such example I've given you. So a socioeconomic status and treatment attendance rate. Okay, this is an HR example, human resource example, and the three factors or three moderators which could affect this direct relationship that you see, socioeconomic status and treatment attendance rate at office, is the miles from the agency, which means the distance from your home to the work, the family support that you have, the multiple jobs you are doing. If you're doing only one job, well and good. If you're doing more than two jobs, this direct relationship will be effective. Okay, so meta regression is an extension to the subgroup analysis that allows the effect of continuous and categorical. Okay, both type of variables can be put inside this direct relationship and be judged. That are they, see, my outcome, what is my outcome? My outcome was the effect size. If that effect size changes, which means this moderator is effective. If that outcome or the effect size remains same, this moderator is of no use. Number one, there are other methods which statistically seeing whether this moderator is effective or not. Sorry, just give me a minute. There are other methods to see if this moderator is effective or not, which is the beta coefficient. So when I put in the moderator, and I have to put in the moderator for all 31 studies, I'll be doing it in the software. So I have to bring in the moderator for all 31 studies, and if the beta coefficient is not 0 and the p-value that the software gives me is less than 0.05, what does it mean? The moderator is effective. It is changing the direct relationship between the two variables, and that is what I'm trying to see. Further, there are a few rules of taking moderators in meta-analysis. Anything less than 10 studies cannot be put for moderation, period. So I have a lot of references for this. There is Higgins, there is Hunter and Smith, there is Borenstein. Anything less than 10 studies will not go for moderation, period. So if you want to study the impact of religion on attitude and purchase intention, out of those 31 papers, you should have attitude and intention at least in 10 papers, number one. Number two, you should be able to categorize those papers into papers done on Christians, papers done on Muslims, papers done on Hindus, at least for 10 out of 31 papers. Only then can you test religion as a moderator between attitude and intention. Okay, so this is a basic difference between regression and meta-regression. Please remember, regression we did on primary data. I went to 500 people. I gave them a scale of traffic and a number of traffic and a number of population, a number of height, a number of age, a number of height, a number of weight. Okay, they gave me, and then I put it up in an Excel sheet, and then I took it to SPSS, and then I did regression analysis. Here we are not dealing with people. Here we are not dealing with primary data. We are dealing with secondary data. We are dealing with papers. We are dealing with correlation value of papers. We are not dealing with people. So please understand that in meta regression, our input is secondary data, unlike regression where our input is primary data. Number one. Number two, the number of respondents in regression does not influence the relationship. But in meta regression, remember, we studied yesterday in the fixed model, the larger the sample size, the more weightage was being given to a study. So unlike regression, where all 500 samples are equal to me, all 500 people whom I've taken is equal to me, in meta regression, weight is definitely given to those studies which are larger in sample size. We have seen that yesterday. On the assumption that larger the sample size, more will be the precision of the study. Okay, In regression, the outcome, the regression is done between outcome and explanatory variables. In meta regression, our outcome is nothing but the effect size. Okay, and the moderators, when you go to the software, you will see a word called covariates. Okay, so the moderator over there, the factor that you take as moderator will be called covariate. Okay, and these can be categorical or continuous. I'm assuming you know what is categorical variables, you know what is continuous variables. Okay, so yeah, there is a bubble plot which will be shown to you. This is very similar. If you people are aware of regression, this is nothing but something like a regression line. It is absolutely, the concept is absolutely similar to this. Okay, so if you know the regression line, I don't think a bubble plot should be too much of a technicality to you. The only difference over here is the circles that you see are studies. The circles that you are seeing are studies. Larger the circle, larger the sample size of the study. So they are based on sizes. Small circles are showing smaller sample size. And this dotted line that you see, okay, so I told you the blue line is a perfect line. Okay, the perfect fit, the best fit line. Okay, and ideally what we want is we want all the studies to fall near the blue line. Okay, because we want a perfect fit, but it does not happen. They are scattered left and right, doesn't matter. They should not go outside the dotted line. Now coming to the question which was asked in the morning, what do we do with outliers? This is not something that I have collected through primary data. So it's not that I was collecting the height of women in India and suddenly I found a lady who was 6 feet 5 inches and she's become an outlier. So I need to remove her from my data. She's destroying my data. She's destroying the mean of my data. No, this is not primary data analysis. This outlier that you see, these two circles that you see outside the dotted line, which you call outliers, are published studies. You cannot remove them. How can you remove them from your data set? You're not allowed to do that. They are published studies. If you remove them, you're manipulating data. You're manipulating the studies. You got 31 studies. How can you ignore 2 studies simply because they showed different results? Simply because they were showing bizarre results, you are removing them. No, you cannot do that. You cannot do that. So what do? I simply report them. In meta-analysis, everything is coming from published reports, from secondary data. There is nothing right or wrong. So don't just get so boggled up that, oh my God, I have 2 to 3 studies which are lying outside the dotted line. Yeah, the whole data is wrong, and I'll have to do the no. You're just reporting, you are describing a pattern to the editor. So these 2 outliers, what do? You just report them. You just report them that, okay, these are the 2 studies which were out of the range of the regression line or the limits of the regression. You just report them. That's it, period. Most of the studies are falling there inside the dotted lines. Thus, this is an effective moderator. Okay, so this is ideally known as a bubble plot. You will see it in the software also. There will be values of Q value, tau, I square, etc. also, which will be given in meta regression. You know how to read them, but I will further be taking them in the software. There is a new value which will come up, which is the R square. You need to understand this. And this is the last thing before we go to the software. So you'll be seeing these tables. If you know the logic, analysis is going to become easier. So you will see this R square value, and it is also reported in research papers. So yesterday, you remember I told you there are 2 types of variance within studies and between studies. It is only the input that you have to give, and the software will tell you what percentage of error is within studies. Here, the within study error is 8%. The software will tell you what amount of variance is between studies. Here it is 92%. If you remember, I told you yesterday, I squares and taus come out of between study errors, not within study errors. And what we are interested in is only between study errors, because these are errors because of research design, different research designs, different locations, uh, different scales being used for attitude. So we are only and only interested in between study error. Now, within study error is by chance, and that is something we were assuming in a fixed model. Here we are taking a random model. So I will go by, what I want is, I want my moderator to justify the between study error. That's all I want. Okay, so between study error 92%, I square 92%, 92% of my variance is coming between studies. I want to see if my moderator, in this case, latitude, suppose the latitude, the place where the study has been done, is this moderator explaining this variance? I repeat, I want to know if this moderator named latitude is explaining the variance. Which variance am I interested in? I'm interested in between study variance. I'm not interested in within study. I'm not interested in within study. I'm interested in between study. So if this chart comes out and the software says yes, latitude is explaining 79% of your between study variance, what is the conclusion? What will I write as an interpretation? Latitude is an effective moderator to explain the relationship between attitude and intention, because it could explain 79% of the variance from the total 92%. This is my interpretation of a moderator. This is the whole process of meta regression. I have done it with one moderator. If you're taking 4 moderators, please do it separately with 4. Okay, there is an option in the software where you can put all 4 of them together also. Okay, so now if you've understood the concept, so this is reporting, this I'll anyway show you. So let's quickly go to the software. Let's quickly go to the software. So this is where we were. Okay, so this is where we were. So let me go to analyze. Okay, and let me go to meta regression. So this is where we left yesterday. If you remember, there was a fixed and random, and so I go to analyze and I go to, sorry, I'll have to enter the data entry. I'll have to do, rather, if I can, I think I'll show it to you on the Excel sheet of Meta Essentials. I think that'll be quicker, and it's a free, anyways, it's a free macro. So I think we'll do it over there. Right. So this was your input. We can go to the input and see that there are, if you go to the input, you will see 2 types of columns which we will have to add. If you are going for a subgroup analysis, you will have to add the subgroup analysis. Here it is AABB. Basically, it could become male, female, Western countries, Eastern countries, sample size above 500, sample size less than 500. It is a categorical variable. You can put it over here in subgroup. Okay, so this is one column you will have to add if you're doing a subgroup. Moderation can be done on continuous as well as sorry, it can be done on a continuous as well as a categorical variable. Here what we have done is, suppose I am studying attitude and intention. Suppose all this data of correlation and sample size is data from 12 papers where attitude and intention correlation values are included. And I want to see the age of young consumers. Is the age of the young consumers in these 12 papers making an impact on attitude and intention? So what do? I go to the first paper by Raw, okay, and I note down the age of the respondent. Suppose, I'm just basing on suppositions because I don't have a real data here. Suppose Raw did a research of attitude and intention on 15-year-old students. And supposing, see, you have to go back to your papers to see which is a moderator, but I'm assuming that I've got a moderator. The second paper, say by Shaw, where my attitude intention value came out to be 0.20, my correlation value of attitude and intention came out to be 0.20, had a sample size of 130 participants, and all participants were 16 years of age. Which is my moderator here? Age. Okay, and what sort of a moderator it is? It is continuous. It is continuous. So my next paper, third paper, correlation 0.96, sample size 80. What were the respondents? They were all 13 years of age. So thus age in a continuous matter here has been added as a moderator column. Okay, I hope adding the input is clear. How do you add an input, okay, to a sheet, okay, to get analysis? So if you're going for a subgroup and a moderator, you will have to add these two columns. You will have to add these two columns in the input. This is the only thing you have to do additional. Rest everything, of course, the macro will do for you. So let's go to the subgroup analysis. Now, this is a subgroup analysis. Just look at it. The category which was marked as, let me use my drawing tool. The data has been divided. There was, say, a total of some 14 papers. There were some 14 papers, and the 14 papers have been divided into all papers which had AA, which means maybe male, and all papers which had BB, say females. It could be Arab, non-Arab countries, Asia, non-Asia, male, female, adolescents, adults, anything. This you will get when you go back to your paper. So the software has divided the category into two categories, and let us see the consolidated effect size of AA, which is, say, males, is 0.92. Okay, and that of females is minus 0.21. Okay, just have a look at these figures. Just have a look at these figures. Okay, and the consolidated effect size when all these 14 papers were together was 0.58. Just take 1 minute to have a look at it. Take 1 minute to have a look at this. So the question here is this male female and an effective moderator or not? Is this A and B an effective variable for explaining heterogeneity? There are two methods of interpreting this. First thing, you have to see the I-square. Look at the I-square of all the papers of male. Look at the I-square of all the papers of female, and look at the consolidated I-square, which we wanted to justify by dividing them into males and females. So my consolidated I-square was 99.33%. I divided the data into males and females, but I still see heterogeneity. Okay, so this variable has not been able to justify heterogeneity. Okay, so this is not the variable which is leading to heterogeneity in my overall data. Okay, now this is an ideal data. What I showed you in the PPT, this is a practical data. What I showed you in my PPT, where the I-square was suddenly turning to 0%, That was an ideal data. It will never happen in life. If it does happen, do let me know. I'll co-author the paper. So here what happens is we have divided into subgroup analysis, but the heterogeneity is still the same. So this factor has not been able to justify the heterogeneity. Now you might ask, am I wrong? No, you're not wrong. No, you're not wrong. You're going to report this. When you make a structural equational model and you write some 10 hypotheses, are all the 10 supported? Are all the 10 supported? Don't you get any one hypothesis which is not supported? Don't you get any one variable which is not moderating the relationship or not affecting the other variable? You do get. So out of 10, when I do a SEM paper, out of 10, I generally get 3 hypotheses not supported. Big deal. I report them as it is. Here also, if there is a moderator, if there is a subgroup analysis you've done, and you see that this variable hasn't led to decrease of the heterogeneity, please report it. And also report the change in effect size from 0.92 to minus 0.21. Okay, you have to report these in subgroup analysis. Just give me a minute. Erase all drawings. Okay, and okay, so this is about subgroup analysis. Further in the same macro, you will get a forest plot also. I somehow find Meta Essentials much more better in visuals and explanations vis-a-vis the CMA somehow. So here in the forest plot, you will get 2 forest plots. Even you get a divided forest plot. So this is the effect size of consolidated papers of male. This is the effect size of consolidated papers of female. These are all the effect sizes of male papers. These are all the effect sizes of the female papers. Okay, it has been divided into 2. So here you have a very clear forest plot also, which has been divided into 2 groups. But this is the analysis part. I'm reiterating to take up to even, you know, this becomes a hypothesis. The fact that you have taken gender, male or female, you are hypothesizing that it's going to affect my bivariate relationship, purchase intention, and attitude. You are hypothesizing. So like when you write a hypothesis in a paper, you always support it with 4 or 5 authors who have said that. You'll have to do the same over here. You will, even before doing a subgroup analysis of males and females, you will have to, in the review of literature, give me 4 authors who say that gender impacts the relationship of attitude and intention. So unless and until you don't justify, you can't even do this. Okay, of course, in this case, my hypothesis is not true. Doesn't matter. There are times when the hypothesis gets supported and there are times when it doesn't get supported. Now let me go to the next thing, which is moderator analysis. Now this is my moderator analysis for the data that has been put. So this is your bubble plot. The red line shows very clearly the best fit. So this is my best fit, and these are all these bubbles are all my studies. So you see this bubble is huge, so it must be having a higher sample size. This bubble is very small, so it must be having a must be having a smaller sample size. If I do an eyeball test, I see a lot of variation from the regression line. From the best fit, I see a lot of variation. From eyeball test, it doesn't look like this is a moderator, but let me go to data to speak for itself. It doesn't look like it's a moderator, but according to what I can see, but just a second. Yeah. So let me check the data. So here I have, just a second. Okay, so here it says moderator. Okay, whatever moderator you have taken, if you remember, we had taken the moderator age, 13-year-old student, 15-year-old student, 17-year-old student. Suppose these studies of attitude and intention have been done only on teenagers. Okay, suppose I have taken 31 studies of attitude and intention only and only from teenagers. So obviously my 31 data will only come from teenagers. So some studies are only on 13 years, some on only 15 years, some on only 17, so on and so forth. So if I have taken up that as a moderator, okay, so you can read out this column. So this column says beta coefficient 0.25 and p-value is 0.000. So my as far as what the data says, I'm not going by the bubble plot. Bubble plot is a very basic method. So the beta coefficient is not 0. Okay, and my p-value for this moderator has come out to be significant. Okay, so Kaushik sir, is the data visible? Should I zoom it? Of course, is the sheet visible or should I zoom it?
Sheet is visible, but
I think it will be.
but it's better if you can zoom it. It will be still better.
Okay, just a second. What I'll do is I'll mark it through the pen. Maybe then they can. So I'll just mark this. So this is the value. I hope it's visible to all. 0.000. This is the moderator. Okay, and it seems to be significant. So if it is significant, which means this is a genuine moderator, it is affecting the relationship. Let me go forward and see the other data. I need the, yes, I needed the R square, which I explained to you. Just give me 1 minute, erase all drawings. Yeah, so I'll use a pen so that it becomes clearer. So if you see there is an R square, which I explained to you. If you remember, R square was the explanation of the between study variance. Okay, and as per the results that I have, I see that the moderator p-value is less than 0.05. Two values I need to say that it is an effective moderator. Age 13, 14, 15, 16, whatever we said is an effective moderator. One is the significance level. It is significant, so it had to be a moderator. Some amount of R square will come. This is very much related to what we did in heterogeneity, if you remember. So there was a Q value, there was a significance value. So if the Q value was significant, there definitely was something in I square. Similarly, if the beta coefficient p value is significant, there will definitely be something in R square. But if at the primary level you see that the p value is not significant, okay, the moderator is not affecting the intention attitude attitude intention relationship, thus hypothesis not supported. In this case, because the p value is less than 0.05, I will interpret, how will I write it? I will write that yes, this moderator age is effectively moderating the relationship of attitude and purchase intention. Also, I will say that this moderator explained 6.05% of between study variance in my 31 studies. I hope regression, meta-regression, subgroup analysis, everything is clear. Let me go back to my paper because we have to see how it is reported in a paper. Just give me a minute. Okay, erase all drawings, and I'm going back to where's the paper? Just give me a minute. I'll have to open the paper again, maybe. Yeah, so this was sample paper. Sir has sent you a link of this also because it has, I've been referring to that paper every time. So he said, oh, this must be the window. Yeah, it's just opening. Give me a minute. finally. Let me see when it, yeah, it's on your screen also. So this was the paper we have been referring since day one. Okay. And in between, somebody had asked about Prisma, so I'm finishing it right here in a very brief method. Okay. Prisma is a protocol that has to be defined for inclusion and exclusion criteria. So I'm very briefly taking it up here. So this is it. Just give me one minute. I'm just, yeah. So this is the Prisma. Okay, this is the Prisma. And this we did yesterday. So we defined the 5 database we took. We defined the number of articles we took from each database. Okay, so you can see Medline, Web of Science, whatever. We defined the articles. Then we say what we removed and why. So he says, I screened them on the basis of title. I removed these many. I screened them on the basis of reference list. I removed these many. Then I removed them on the basis of language, or maybe because they didn't have a quantitative value. So at every step, he removes articles, he includes articles, and finally he says, I've done a study on some. So in this case, he says, I finally did a study on 22 articles. So Prisma is nothing. It's a protocol which has to be followed to define what you took as inclusion and what you took as exclusion. So this paper is with you. You can study it in detail. Okay, how he rejects, and I had explained yesterday, language could be a parameter, not having correlation table could be a parameter. The study not in your context could be a parameter. So there are parameters in which you exclude or include studies. When you write about what you include, you write about the 5 databases. You write about the keywords you used in those databases, and then you say you did a full screening and then you included the papers. So you have to define how you included, how you excluded. So that's about Prisma. And let me go to reporting of, yeah, so this was my table yesterday. This is where we had stopped, if you remember. So I was on attitude, intention, and I had reached Q and I square. This you remember. Okay, very, very high heterogeneity, 94%, 90%, and they have reported it also. So, and they should report it. Why should you? It's not my fault. I mean, they're secondary published papers. I shouldn't be manipulating them anyways. Okay, so later on, what this guy did is he's done something called a subgroup analysis. Okay, this paper shows only subgroup analysis. Okay, so just see, he has divided people on the basis of age. So he says out of all those 22 papers that he has taken, he says he has taken papers where the sample was less than 17 years. He has taken a second subgroup category where the sample was 18 to 29 years, and then he's taken a, just a minute, then he's taken a third category where the sample is, I better zoom it. I hope now it is visible. I hope now it is visible. Okay, so he's taken 3 categories: less than 17 years, 18 to 20 years, and more than 30 years. How did he take this category? He went back to his paper, he saw the samples, and he found this could be, the age of the sample could be a varying factor, okay, in my study. Again, please see, he has taken for attitude intention, please see that row. He says for less than 17, he got 4 studies, okay, and his effect size for this subgroup, which was less than 17, came out to be 0.58, okay. 1359 is the total samples which came from these 4 studies, which were less than 17 years of age. His heterogeneity values are still high, okay, but I have read his analysis. What he's written is how he's not said that this is an effective moderator. He's not said that this is effectively impacting the attitude intention. He says that how he has interpreted, I'm just telling you the written lines he's written. He has written that among just so he writes that if you see the effect size of these three groups, so this is 0.58, it is 0.68 and 0.56. So how has he written his interpretation? He says the attitude and intention relationship is strongest in the category of 18 to 29 years old respondents. This is what he has concluded. See, he has found out an effect size of each category, each subgroup, 0.58, 0.68, 0.56. There is a difference, although a minor difference. Okay. So in his interpretation, I have read the papers, so I'm telling you. In his interpretation, he's clearly written that attitude and intention relationship is the strongest in the group 18 to 29. Okay, so I can show you other also. For example, look at the effect size of this bivariate. So 0.41, 0.38, 0.28. So he has written this relationship, whatever it is, it might be intention, subjective norm, whatever it is strongest in the participants who are less than 17 years. Now, come to the managerial implication. If I say attitude and intention is strongest, somebody has reported out of what? Again, what are these findings out of? 200 papers in the past 20 years. Suppose I am opening a new brand by the name of a sustainable brand called Jaspreet Sustainable Garments. And I want to know which is that category whose attitude is very strong to buy sustainable product. Which is that category in India? And somebody comes to me with this report and says, ma'am, I have analyzed some 200 studies and come down to 20 studies where attitude intention I have analyzed, and out of those 200 studies, the summary is that attitude intention is very, very strong in the 18 to 29 years category. What is the managerial implication of this? The managerial implication is that I will launch my product and the advertising of the sustainable product only and only for the 18 to 29 years category. This then becomes my target segment, because in a sustainable product, attitude is very important. If the person's attitude is सब चलता है, क्या फर्क पड़ता है, environment बर्बाद होता है तो होता रहे. If this is the attitude, he'll not buy my product. I have to have a very strong attitude, impacting intention for a target customer of sustainable products. And if such a person comes to me with a report and says, listen, it is strongest in 18 to 29 years of category, ma'am, what will I do? I will make my target segment for marketing of my product to 18 and 29 years old category. And this is exactly what he has concluded in managerial implications after a subgroup analysis of this whole data. Okay, so I am on time this time. Yeah, it's 11:15 and I've explained the concepts, and we can now open the house to questions. Sankaran sir, will you be? Okay, so I'll cover the last topic for my session, which is publication bias. Okay, and publication bias, although I'm doing it as a last calculation, but ideally I somehow feel that even before calculating effect size, I should be doing this, because if this comes, this is one value which should not. I said in meta-analysis, there's nothing right or wrong. We have a pattern, we just write it. But this is one value which can really lead to wrong interpretations. This value, if seen negative, can lead to a wrong, a negative comment from a reviewer. So this value has to be right. Okay, and let me tell you right in the beginning that when we are calculating the publication bias, and suppose God forbid the publication bias is seen through the values it is seen, the only and only thing you can do is go back and collect more data or look at your data set again. So ideally what I feel is, even before doing the effect size that we started with yesterday, we should be calculating the publication bias first and seeing whether my data is biased or not. So that is, ideally I feel this is the first thing we should be doing, because and it's not that in all the rows that you see, in all the bivariate relationships you see, the publication bias should not be there. There are papers which have reported that if I have 8 bivariate analysis studied, one odd analysis I had a publication bias. It's okay. Okay, it's absolutely fine. But if I have 8 bivariate relationships and all 8 have a publication bias, or 6 have a publication bias, there is no reason I should be going for a analysis. So let me come to how do you calculate publication bias. Okay, there are many methods. I'll be covering a few. So what is a publication bias? I have explained it through this picture. So this is a tutor who has given a little more bias towards probably the female students vis-a-vis a male. And this is exactly what the bias means. It means a substantial problem of credibility of research in meta-analysis. So, if your publication bias is persistent through statistical analysis, it shows that there is lack of credibility of your meta-analysis. So this is a very, very important figure. Maybe that is the reason that many people don't even report it. So I have seen many research papers where people have not even reported the publication bias, but ideally you should be reporting it. And publication biases happen because of what reasons? Okay. So as per Egger et al., 2005, a location bias can happen. I could be a little biased towards taking Asians. Okay, so these are the reasons I'm telling you why the bias might having. A selective outcome reporting. Maybe as I said, I'm a little biased towards SEM papers. I could have taken up a t-value, I could have taken up a p-value, I could have taken up a beta coefficient, but I'm very, very biased. I say, chodo yaar, who's going to do all this? Let me only concentrate on correlation, papers which report correlation. So that is a second bias. There are other factors also, that the bias might only happen by chance. Okay, so it's not necessary that you're doing it purposely, or there's an inadequate analysis, or there's a fraud. No, it could happen by chance also. But whatever the reason be of that bias, taking known authors, taking only published papers, taking one language papers, taking citation based bias, so the more the paper is cited, the more I have the chances of pulling it into my study. These are very normal bias. These are not bias that people don't know about. These are most of the bias reasons because of which researchers pull in good papers into meta-analysis and leave the unpublished, leave the dissertation, leave the student and conference papers. Okay, so this all leads to a bias, and this bias is what is the problem. Now, one very big problem in reporting bivariate correlations, okay, a topic which we did yesterday also, while there was a question answer session in which someone said, should we take significant studies or not? So let me answer that this way, that we are supposed to be taking non-significant studies too. But unfortunately, when we read a paper, so if this is my hypothesis values, most of the times the correlation values which are given are significant, because most of the published papers only report significant values, and the fact that the paper is published is because you're showing some significance. So I remember in one of the FTPs where I went, where one of the workshop people said, they said, why would people want to know that something is not significant or does not affect? I mean, that is known. If it affects, tell me. So it's like a medicine, you know. Would you like to know all those COVID vaccines which did not affect the people? Are you interested in that? No. You are interested in which was the most effective COVID vaccine that affected people. So there is a bias, you know. We just take up significant studies, and we don't take up insignificant ones. There is a sample bias, okay, and this has all been said by researchers. So Hedges says that there is a bias. We don't like taking studies which are smaller in the sample size. We like taking studies which are very huge in sample size. Even that is a bias. Although when it comes to the software, the studies which have a higher sample size will have a better precision, and they'll be given more weightage in fixed method. I agree to all that. But as a research, as a collector of studies, you're not supposed to be keeping that bias of small sample size. The moment it is attitude and intention, there is a correlation value, just pick it up. Whether it's positive, negative, whether the sample size is big or small, whether the value is significant or not significant, you're supposed to be, I'm going by the books, you're supposed to be putting it into your analysis. There is a bias towards unpublished papers. Okay, so why talk about others? Even I, when I'm making a paper, not for a meta-analysis paper, because I do take conference papers, but I have a bias towards conference papers. I don't think they are authentic enough vis-a-vis a published report. So in my other studies where I'm not doing a meta-analysis, I don't even take conference papers. I don't even consider them, okay, because they are not published. I don't take student dissertations in my other papers. So published papers, we are a little biased. We are biased towards language, but I think this is a genuine bias. I'm just listing the reasons. I'm not saying they are wrong or right. Now, just see the script that you see in front of you. Can any of you read it? Can any of you interpret it? So if I can't read it, how can I take it up as a paper? So language bias is there. There's a bias of studies which are easily accessible. So for example, there's a PDF file which is easily accessible. I tend to take those rather than taking those which are paid, or for which I'll have to go to MDI Gurgaon and get them, you know, downloaded. So there's a bias towards easily accessible databases. Okay. There's a bias of studies which are available at a low cost that I've shown. There's a bias. I am also a little biased towards this one gentleman who's the father of sustainability. So I'm a little biased towards studies. When I do sustainability, I get biased towards taking papers of only Dr. Bell or Dr. Sheeran or Dr. Whittle Scott, because they are the fathers of that particular study. There's a bias of citations. We generally tend to take papers which are highly cited vis-a-vis which are low in citations. So I'm just bringing in the reasons of bias. Now, first thing first, the bias has come. Okay, I'm assuming that the bias has come and I have to measure that bias. How do I measure that bias? So I'm telling you, I'm going to discuss three methods. One is the funnel plot. Okay, another will be the fail and safe end test, and the third will be the trim and fill test. So I'm going to discuss three tests over here on the basis of the amount of time I've got. I will be explaining each in detail, and I will be finishing at 1, because I know there might be a lot of questions lined up since yesterday and today's session together. So I'll be finishing at 1. I'll try to take up all three in detail, because the understanding of the essence of the method is more important. The software takes 1 minute. It's not even taking 1 minute. Meta Essentials is not even taking 1 minute. You don't even have to go to analyze. You just have to know how to read data. And that is what I'm trying to do before I go to Meta Essentials. So there's something called a funnel plot. Yesterday, I showed you a paper also where that author had reported a funnel plot for every bivariate relationship. Okay, this funnel plot that you see is only for one bivariate relationship. I'm still on attribute and intention. And this is a funnel plot. Now let me explain to you what's a funnel plot. This funnel plot is made at a 95% confidence interval, and these dots that you see, these are all your studies. Okay, these are all your studies, and they have been plotted in the shape of a funnel. Okay, so what is there on the axis? Let me show you. So on the y-axis you have a standard error, and on the x-axis you have, here it says odd risk ratio, but primarily it is the effect size. Okay, so effect size could be on the basis of correlation, it could be Cohen's d, Hedges g, odds ratio, whatever your effect size is, that is plotted on the x-axis, and the effect size is also known as the study result, okay, because it's the final effect size. And the standard error that you're plotting is also known as standard precision, of how precise, how error-free your or authentic your study is. Now that we are plotting our studies into the funnel, how do we interpret whether there's a bias or not after seeing all this? How do we interpret? All our studies should primarily lie inside this so-called funnel. Okay, so as we say in Hindi, the Lakshman Rekha is this dotted line. All right, so nothing should go outside this dotted line, and if at all it goes, I mean, I'm also telling you, I'm not telling you the idealistic figures. If at all it goes, it is absolutely fine if one or two studies go outside this. This is a very, very, very subjective method of deciding whether there's a bias or not. So in this funnel, which of course is a perfect funnel, because all the studies are lying inside the funnel, thus I conclude that there is no publication bias. Okay, with this, if there are a few studies, one or two outside the funnel, I can still conclude there is no publication bias. But I'm going to show you a disastrous funnel in Meta Essentials, where you will see all the studies are lying outside the funnel. Now, this is your danger point. Okay, so if you have collected 31 papers and you have done a funnel plot analysis or a publication bias analysis, and all the studies are outside the funnel, which means there's a major bias problem, you better go back. And if you're getting it in one bivariate relationship, doesn't matter. So you must be making some 8 funnels for 8 bivariate relationships. Okay, so if you're getting it for one relationship, doesn't matter. But if it is consistently happening for some 6, 7 relationships out of 10, you better go back, change your data set. Don't they see, and this is not something which is new. As I said, when we are working with a technique called structural equational modeling, SEM. So sometimes when our model does not run, what do? We go back and collect more data. The first thing I try to do is collect more data. I make the sample size from 300 to 600 or 800. Then the model might run. Okay, so that is the first thing that I also do here. I see if there is any paper. See, the fact that a funnel plot is listing all studies outside, or the fact that there's a publication bias, means you have neglected studies. What is the layman interpretation of this? The interpretation is that there were studies in the domain of your subject and you have not taken them. Okay, so that is the reason that the funnel plot is not evenly distributed. Okay, the funnel should be evenly distributed, but it's not, because you probably did not take all the studies. So what should you be doing? You should be searching more, listing those studies which you haven't taken. So this a bad funnel plot simply shows that you've not done enough of data research. before starting meta-analysis, period. Go back, increase your data, again do the analysis, and it should somehow fit within this triangle. So this is the first test of publication bias. Okay, this is what a practical funnel plot looks like. What I showed you was an idealistic one, and this is what generally a practical funnel point looks like. So you might have 1 or 2 studies outside, and also it is said that the funnel should be evenly distributed with studies. You know, same number of studies in this part and the same number of studies in this part, but as you see, okay, that is also not happening. So we have 1, 2, 3, 4 studies on the left. We have some 7, 8 on the right. So that is the purpose of showing this funnel plot, because this is what normally happens. Okay, this is not an ideal funnel plot. This is what you will get when you're doing actual meta-analysis. Okay, so 1 or 2 studies outside. So fairly it shows, yes, there is no publication bias. Most of your studies are inside the funnel. Thus, there is no publication bias. Okay, so this is what you report after looking at this figure, and you can very well see how the software has plotted it. So if this is your effect size, so you know, if it is this study, so this will be its effect size on the scale. If it is this study, then this is the effect size on the scale. So this is how the plotting is being done by the software. All right. So this is about the funnel plot. It's a very, very basic method of publication bias, not a very authentic one, but this is one of the methods. Now let's go. Okay, this is what is a problematic funnel plot. So if you get something like this, you better go back and check. I mean, it's absolutely unevenly distributed. Many studies are falling to the top or the tip of the funnel, and the studies are actually pouring out. So you can see these are problematic funnel plots, and if you get such, God forbid, if you get such a funnel plot, you better go back and check data and do something about your data. All right, so if God forbid you get this, it's going to be too much of a work. Okay, now let me come to my second type of publication bias, which is called a trim and fill concept. So let me explain the concept in a very simple way. In an everyday example. Okay, so and the grains that he's collecting become the research papers. Now, when a farmer collects the grains from his farm, there are 2 or 3 rotten grains also which come into his pallet. So what does the farmer do? The farmer trims and fills. So what will he do? He has to give you, say, 1 kg of wheat, and he has some, say, 5, 6 corrupt or dirty grains in his pallet. So what does he do? He has to give you 1 kg of wheat, period. What will he do? He will remove those 5 rotten grains, substitute it with 5 good grains, and then give you 1 kg of wheat. Now put this put the researcher in the shoes of the farmer. This is exactly what the farmer is going to do, what the researcher is going to do in the trim and fill. He will add in 5 good grains to normalize the funnel plot, and see how he's going to do it. When you look at funnel plots, there is an idealistic funnel plot. Okay, so I told you this one is a symmetrical or ideal. Why? Because look at the number of studies on the left, look at the number of studies on the right. They are almost similar. They are almost similar. The funnel plot is symmetric, but this doesn't generally happen in research. What happens is that you get this sort of a plot, 3 studies to the left and a lot of concentration on the right. Now, what do you mean by concentration on the right means? You mean that out of 31 studies, some 20 studies are showing an effect size on a higher range, and some 3 studies are showing the effect size on a lower range. Thus, they cannot be averaged out, they are not uniform. Okay, now this asymmetry in funnel plot is removed by a process called trim and fill. And what do you do for that? Let me tell you. See, you will do a trim and fill only when there's an asymmetrical funnel. Okay, you will not do it for a symmetrical funnel. A symmetrical funnel means you don't have a publication bias at all. In an asymmetrical funnel, let's see what the software will do to rectify it or tell us how much is the publication bias. So let me see what the software does. So what the software does in a trim and fill test is that if it sees that there is an asymmetry over and there are lesser number of studies, it will count how less are the studies, and it will fill up this part with what we call pseudo studies. These are the good grains that the farmer has put into his pallet to make that 1 kg of wheat. Okay, and thus the method is known as trim and fill. So what has ideally the software done? The software has seen that there's an abnormality in your funnel, and it has seen that the funnel is not balanced on both the sides. So what has the software done? Through some calculations, it has added some pseudo studies. Some say 1, 2, 3, 4, 5, 6, 7, 8 pseudo studies. And the interpretation of this is that these 8 studies, in a way, have been missing in your database. It is like saying your database is biased. And if you add these 8 studies, the data will become unbiased. This is what is the layman meaning of the addition of these studies. Okay, so this is what the software is going to do. I just told you the process it's going to do. Now, I think it is very, very clear that lesser this number, the better it is. If the software tells me, listen, you have total 31 studies and you need to add 10 more studies to make this data unbiased, is it a good sign? I mean, 1/3 of my data is biased. Is it a good sign? It is not. But if in 31 studies, the software tells me, okay, you have to add only 1 study more, 1 good grain more into your palette to make it unbiased. Is this a good result? Yes, this is a good result. Now, again, it is a very, very subjective interpretation. How many studies are good to be added, or what is the percentage of studies which are good to be added or which are bad to be added? There is no such reference I have got ever that these many studies are okay or that many studies are okay. This is a fairly subjective evaluation. Okay, so if you have 31 studies and I say that the software tells you I'll have to add 15, obviously you have a truly biased data. If out of 31 I have to search another 15 studies to put inside, it's a fairly biased data. You better check your data now. You better go back and recollect your data so that you could make it better and remove this bias. But if it's like 1 study, or suppose, I mean, there are times when the software says 0 studies, so you can have a party after that. If the software says 0 studies to be included, which means there is just no publication bias. Again, the interpretation of this, you will be doing many bivariate relationships. You are doing 8 to 10 bivariate relationships. In one odd bivariate relationship, if you have a higher number of trim and fill, say 8 studies or 10 studies, it's okay. Report it, show it. But if you are getting the same publication bias for 10 bivariate relationships, or say 8 bivariate relationships, all 8 meta-analyses are showing you that 8 studies are to be added, 10 are to be added, 30 are to be added, that means there's a genuine problem in your data collection. I have shown you the methods of bias, okay? And in case you see those methods of bias, please work on them. Please work on them. There are people who work on language papers also, by the way. So they ask for an English version, or they get it converted to an English. So there are people who do that also. Okay. So the trim and fill method is only going to tell you how to replace the omitted studies. Okay. So there are omitted studies, because on the right side you see there are lesser studies. They should have been there. The graph should have been uniform. It's not. So what the trim and fill is going to tell you, the number of studies which has to be fitted in to compensate for the omitted studies. Okay, and this number should be less being a subjective term. I till date haven't got a reference where I come to know what is the exact number of trim and fill to say that the bias is biased or it is not biased. But I go by a fairly subjective evaluation of that number when it comes to trim and fill. Let me see how I report trim and fill. So this is the method of reporting trim and fill, and let me explain this to you. So let me go to the first thing. This is what you have to read. So you will be given a corrected value. Okay, so corrected value, or the number of studies which had to be put into the funnel, is 0. Again, I'm showing you a perfect data. I'm showing you a perfect data. I'm showing you an idealistic data so that you understand the relevance. When we go back to our meta essentials, the data is really disastrous. So that is a real-time data. On my slides, I have perfect data. On my Excel sheets, I purposely have a disastrous data so that you see both sides of the picture is not always rosy. So the corrected values, it says 0, or excluded studies, it says 0. So which means that you have not excluded any study, you have not left out any study. Your trim and fill value is 0. What do you mean by 0? The software did not have to put even a single pseudo study into the funnel to make it uniform. This is what it means. So what is the interpretation of this? The interpretation of this is that not even a single study is missing from your data. So not even a single study has been left out from your data. Thus, a perfect, unbiased data you are having. Okay. A second way of reading out the trim and fill is through what we call the point estimate. I have said once again, even in the software, we saw a term point estimate. Point estimate is nothing but your consolidated effect size. Okay, I'm still on attitude and intention. All this is happening only for one bivariate relationship, attitude and intention. I'm still on that. So for attitude and intention, the point estimate, observed value is originally, okay, when the software had not fiddled with data, had not filled in the funnel plot, the original studies, the original data gave a point estimate effect size of 0.41, and after the trim and fill was added, which means 0 studies were added, the effect size was absolutely same, which is 0.41. If the trim and fill gives you a result other than 0, suppose it says 2 studies were added or 4 studies had to be added, obviously this effect size will change. Okay, so the moment the trim and fill says you had 8 studies excluded, you report there's a publication bias. The moment it says that the point estimate has changed from the observed, what do you mean by observed values? They are your original plot. That is your original plot, your original 31 studies. And what is the corrected value? In those 31 studies, the software had to add some 7-8 studies to make it even. So that is the corrected value. So from the observed value, which is your original data, to the converted corrected values, which is the manipulated data by the software by adding some good grains into your funnel, there will be a difference in point estimate. There will be a difference, and you report that and say that my study is biased. Okay, I hope you don't have to report that, but in case you do get a bias, you will have to report it. You cannot go without reporting a bias. Okay, so that is about trim and fill. I'll be showing it to you in the software. And when you see Meta Essentials, it has some, if I'm not wrong, some 8-9 types of publication bias. Okay, it's not possible to complete all. I have done a funnel plot. I'll be doing trim and fill. I'll be doing fail and safe and I think Kaushik sir's video has more bias explained, but there are some 7-8 types in Meta Essentials. As the macro, all those I have not explained. I'm just taking up the major ones I have seen in research papers. So funnel plot is always there, trim and fill is always there, and fail and safe is always there. So that is what I'm covering. Now, let's come to the third type of bias, which is a very interesting. I read it as a story, so I'm explaining it as a story. So what you see on the right side is actually a researcher. What you see on the right side is ideally a researcher. She's, while collecting data, you can really see, and this is not just a researcher, it's a researcher team of 3 people, if you remember. And she's collecting data, and she's got exorbitant number of studies. She's going mad with 200 studies on her desk, and she doesn't know which to take, which to leave. And obviously with the bias that I've explained to you, language bias and this bias and that bias, there's a very important bias which Rosenthal did not like. So Rosenthal did not like one of the bias that I've listed, which was taking only significant relationships. Rosenthal said that while a researcher selects a bivariate relationship correlation from those 31 papers, or from those 200 papers which landed to 31, the publisher, the researcher is biased towards towards significant relationships, and this is what Rosenthal said is wrong. He also said that this poor researcher who's fiddling with papers is one who's going to leave these insignificant studies which might be present in unpublished studies. So Rosenthal says that there are unpublished studies and you don't take it up because probably the values are not significant. Probably the papers have been rejected for the fact that the values between the two bivariate weren't significant. So Rosenthal says that you have a bias, the researchers have a bias towards taking only significant studies, and this is wrong. So he named this as a file drawer error, okay, or a file drawer bias, okay. And what does he mean by a file drawer error or a bias is that he says that what you do is, we purposely do, he says, that the researcher puts all the insignificant studies into a drawer and just locks them up. Sorry. So he says that the researcher will just lock up all the insignificant studies in a drawer and just in a biased method pick up studies which are significant. So what fail and safe and test does is it pulls out from that closed drawer. What does the closed drawer have? The closed drawer has insignificant studies which you left out, which you did not take in your meta-analysis. So what does the fail and safe test do? Based on the same input, the input is same. When we go to meta essentials, the input will be same. The same correlation, the same sample size, the same everything. But from that input data, the software will pull out the number of studies which you put into the drawer. Which studies? Insignificant studies you put into the drawer and shut it, or those papers which you should have taken for meta-analysis but you did not take. Okay, I repeat, the fail and safe end tells you a number. It will give you a number. It will come out with a number. And that number, according to Rosenthal, is the number that you have left out, the number of papers you have left out, or you chucked it into the drawer simply because they reported insignificant values. Number one. Number two, as per Rosenthal, if you bring out these papers, and you add it to your present database, what was my database? My database was 31 studies. So Rosenthal says that despite the fact that you've neglected it, but now if I bring out these number of papers, say 20, 35, 25, whatever number comes out from analysis, if I bring these papers or add these papers to my 31 papers, my effect size will become 0. Okay, so just imagine the repercussions of this. I did an analysis of 200 papers, then I came to some 31 papers, then I've calculated effect size, then I've got my moderators, everything is done. And now suddenly there's a value, and the value is very high. Suppose my total papers are 31 and the Rosenthal fail and safe value comes out to be 25. Okay, so what does it mean? It means your study has 31 papers. There are another just 25 papers which you need from the world of research. 25 papers from the world of research which will have insignificant p-value for the same bivariate relationship, attitude and intention. And the moment they come out of the world means the moment another person searches these 25 papers, the effect size of all your 31 papers that you have just calculated goes down to 0, which means your research becomes nullified. So that are the, although a little melodramatic, but that is the repercussion if you get a fail and safe and test value which is not that good. Okay, now there is a benchmark that I found for Rosenthal fail and safe. Okay, and the benchmark was this, and this is a benchmark not only for meta-analysis. I think, as I said, many of the meta-analysis concepts come from basics of regressions and correlations and all that. So this is an ideal value even when I do primary data analysis and I'm told that I have so many items. Okay, so items is statements. So I'm always told that I take 5 times my item plus 10, and sometimes I'm told 10 times my item, the sample. So if I have 20 statements in my questionnaire, I should be taking 20 into 10, at least 200 samples. So that is always the case with data in previous studies, in other research methods also. So this is what has come out, 5K plus 10. Here K, of course, as was there in the table also that I showed you of the research paper, K is the number of studies. So if you had 30 studies, okay, so 30 into 5 is 150. 150 plus 10 is 160. So when a fail and safe Rosenthal value comes out, the value should be more than 60 papers. If it is more than 60 papers, there is no publication bias. If it is less than 60 papers, you are standing at a very dangerous edge. Another 50, 55 papers from the world of research, which is very, very easy to get, with insignificant studies, and your whole meta-analysis calculation boils down to 0. All that hard work that you have done boils down to 0, right? So if this number is high, you better, you have to check, you have to go back, check your data, increase your data, see where the bias happened, try and work out on the bias, and then make it unbiased. So this is about Rosenthal fail and safe. It is also called the file drawer test. Just give me a minute and I'll show you how, sorry, erase and come to normal. Yeah. So now this is how it is generally reported. So there's a fail safe, and the most important value over here is this one. All right, so 6027, this is the value you have to read. So if I have 31 papers and the fail safe n comes to 6027, okay, so here what you see is number of observed studies. So number of observed studies means the number of studies I have taken, total taken. Okay, so this person from whom I've taken the table has taken some 22 total studies in meta-analysis, and his fail safe n comes at 6027. So from the principle of 5k plus 10, I think he's very, very safe. So he's taken 22 papers and he needs another 6,027 papers from the world, and all insignificant papers to come to light for his effect size to become 0. Okay, so that is what is the that is what is the effect size. Now alpha shows that the effect size is of all these papers, 6027 papers, the significance level will be less than 0.05. Okay, so as I said, Rosenthal primarily complained about not taking studies which were significant. Okay, significance level less than 0.05. He was against that primarily, and rightly so, because he says there should be no bias in data. Okay, so this is the way you report it. Now I have exactly 15 minutes, so let me take you to the software. There is another test which I do explain, Orwin test, but I don't have time for it, so let me stop at these 2 tests. And of course, as I said, there are some 9-10 publication tests. I have done the 3 types which are most common in research papers. So if you've gone through a meta-analysis research paper, fail and safe, trim and fill, and funnel. These are the 3 tests which I have generally. I've also seen the Eggers test, but of course that is there in Meta Essentials. You could see it in YouTube videos of Kaushik sir also. It is very much there. So let me come to back to Meta Essentials. Okay, so this is my input data. Okay, my input data is just the same. I don't have to touch the input. It is same. Don't worry. Okay, and I also to consider this, I don't need these 2 columns. Okay, so if you haven't done a subgroup analysis or you haven't done a moderator analysis, it's absolutely fine. Okay, you can actually see your publication bias even without doing a subgroup and moderation. The data that I need is for the calculation of publication bias is merely this. Okay, so ideally suggested is that when you've made your Excel sheet, now this is the data taken off an Excel sheet of attitude and intention. Okay, so you have 12 studies of attitude and intention, and if you have taken out this Excel sheet, preferred is that you check the publication bias first. before checking the moderator or the subgroup analysis. You should ideally do the publication bias first for each of your bivariate. I'm doing it only for one. I'm still at attitude intention, but you have to do it for all 8. So this is the publication bias sheet you can see here. So as I said, there are many types which have been explained in Meta Essentials. I will go to this one, which is the yeah. So this is your funnel plot. Okay, this is your funnel plot, and as I said, this is a quite a disastrous funnel plot. You can see. So you see that there is no study inside, and all the studies are lying outside, and you can come across. So what do you interpret from this? You've seen quite a good funnel plots in the slides, but these disastrous ones show that there's a very high publication bias. Okay, all the studies are outside the funnel, and if you ever get this sort of a funnel, you better go back and check your data collection. There's something drastically wrong in your data collection when all studies are falling out of the funnel. So this is one of the disastrous funnel plots where you would need something to be done to this. Okay, and let me go forward. I'll have to shift a little towards the right to find my fail and safe. These are all different plots which can be done for publication bias. I have just explained one. These are all publication bias plots. So here you have the Rosenthal fail and safe value. Okay, so so this is your Rosenthal fail and safe value. It stands at 5932. And if you go back to the input sheet, the data is merely of 12 studies. So 5n plus 10, I'm going by that principle, and I'm citing Rosenthal for that value. So 5 into 12 plus 10, so that's 70. This Rosenthal fail safe is way ahead, I mean, way larger than 70. So definitely there is no publication bias, and thus the hypothesis that there's a publication bias has been called as false. Okay, so that is what is listed. Orwins I've not done with you. Okay, so fail-safe end test could be of many types. So there's Rosenthal, there's Olkin, Orwin, which I wanted to do, but due to lack of time, Fisher's. But primarily what I've seen reported in most of the research papers is the Rosenthal's fail-safe test. This is the most popular as far as what I know about publication of papers. Okay, and I'll have to check if it has a trim and fill. If it doesn't, I'll have to go to CMA to do it. But my aim is that I show everything on a free platform rather than going to a paid one. And then you know the CMA now. So I have a fail and safe. Let me see. I don't think there is a trim. Kaushik sir, is there a trim and fill in Meta Essentials? I don't see it.
Yes, just
Do we
please.
have a trim and fill? It's there. I don't see it here. I'm going through all. Egger's regression is again very, very famous. So let me see again. I'm working on the sheet. Maybe I've missed. So so funnel plot. See in the orange color, Egger's regression. These are all publication test, standardized residual histogram, Galbraith plot, Galbraith plot also I've seen in some papers, normal, quantile plot, fail and safe and tests. And that's it, sir. I think I finished the sheet. I don't see a trim and fill somehow. I don't know if, oh yes, there is a trim and fill over here in calculations. Okay, so you can see the value of trim and fill over here. So -1, -7, +4, 6, 9. Okay, so this is where the trim and fill has been reported. Okay, so and you know, trim and fill means I have reduced a few studies, added a few studies, so on and so forth. Okay, so that has been reported here for every study or every bivariate relationship. Right, so that is about it. I have 8 minutes. Maybe I could take you to, I have to take you to the paper to show you how it's reported. But before that, I think I can take you to CMA and just finish the process. Right, so we were at analyze and we went to run analysis. I'll just, because we have 8 minutes, I can just show it. You don't see it. All right, so we go to analyze and there's something called a publication bias. Okay, so you can see this. You go to analyze and there's something called a publication bias. So I go on the publication bias, I click it. And here is my funnel plot. This is the funnel plot as it shows in a CMA software. I further can go to view. You can go to view, and in view it will show you all the options that it has of publication bias. So it has a funnel plot, it has a fail-safe n, it has a rank correlation, it has a regression test, and it has a trim and fill. So let me go to fail-safe n and see what is the data. So he says, the software says some 638 studies are needed to nullify your effect size. So that's way too high. I mean, if you remember, the input of the CMA was merely 5. For the sake of demo, I had merely taken 5 studies. So for 5 studies, if 638 studies are needed, that too insignificant to nullify my effect size, I think I'm way too safe. Further, let me show you on CMA the so computation, analyze, computation, no, view. Go to view and you can go to trim and fill. All right, so in trim and fill, the most important, of course, you don't need to read the whole table, but the most important, as you had seen in the slide also, so there's an observed value, which is your original 5 studies, and there's an adjusted value, which is the number of good grains he had to put into the palette. So he's put in 0 grains. So he didn't have to put in any study to your funnel plot to equalize it or to make it uniform. Thus, it shows that there is no publication bias. More so, while reading this, it's the same as it was in the PPT. Because there is 0 studies included by the software, there was no need of adding any study for making the publication bias okay. Your publication was there was no bias actually in your data. So that is the reason it had to put in no studies. And because it had to put in no studies, the point estimate, and point estimate is nothing but the effect size, is also same for both. And over here it will show you the effect size observed and adjusted. Adjusted means when it has to add the grains. So it will show you the fixed effect size of observed and adjusted. It will also show you the random effect size observed and adjusted. So if you're working on a random one, you take this. as your value and report that there's primarily no change in effect size. Thus, my data is absolutely unbiased, and there is no study added by the software also. So my data is perfect. So if I go through, if I analyze this data, and let me show you the data. So I'm safe on fail and safe. I'm safe on trim and fill. I just want to go to the funnel plot and show you that sometimes the funnel plot may look disastrous, but you have to find out a fail and safe or a trim and fill too, because if you see a funnel plot is also an eyeball test, and eyeball tests are never 100%. Okay, so you see out of the 5 studies, 3 lie outside the funnel. So despite the fact that the funnel plot does not seem to be okay, the fail and safe and trim and fill say that there is no bias. So what I mean to say from this analysis is, don't just go by the funnel plot. Funnel plot is a basic eyeball test. It is not a it's not a confirmed test. You will have to go further to fail and safe and trim and fill. All the more reason that people don't report funnel plots. Okay, so these were your studies. If you remember, there were barely 5. Okay, so Rosenthal was some 2000 something, which is way too much for my data to be proven biased, and the effect size coming down to 0. So Hindi में कहावत है, कब नॉर्मन तेल होगा कब राधा नाचेगी, something like that, you know. तो कब 2300 स्टडीज निकलेंगी, कब मेरा effect size 0 होगा, it will not happen. So I'm safe. So that is probably what the fail and safe means. So this is about it. I think I'm on time and I've finished my session. I've shown it to you on 2 softwares and 3 tests. I think we covered funnel plot, fail and safe, and trim and fill. Right. So this is about publication bias. Now I think we can open the house to questions. I think it'll take another half an hour.